Actually, two.
Thank you. Hi, I'm Aviv Laufer. I'm the CTO of Rounds. Personally, I've been in this industry for, I think, over 20 years, almost 25 years, doing all sorts of stuff, from embedded development to large-scale web and mobile. I used to manage shopping.com, super derivatives, etc. Also developed for 6 years of medical devices embedded as a developer. So I've done a lot of stuff during the past years with around Aviv. A little bit about Rounds. Rounds have been around for about 7 years. We're about 35 people. And most of us are in R&D. Little over it. We're Tel-Aviv based, just across the street. We just moved to new offices in an old building in Sarona. Over the years, we raised about $22 million from companies like Sequoia, Samsung, etc. And we have 25 million users around the world. Historically, Rounds has always been an area of video chat. So we tried different areas around video chat. We used to have a Facebook application, desktop application, something like chat roulette, etc. And in the last 2.5, 3 years, we are very much focused on the mobile. So this is basically a screenshot of our application for the Android and for iOS. It allows you to do one-on-one video calls or group video calls, and during the call you can apply effects, scribble over each other, take snapshots, play games together, watch synchronized YouTubes, etc. All of it in HD and above quality. Okay. So what tools are we using? On the client side, we use Objective-C on the iOS and Java on the Android, and bits and bytes of C++ and C for our video engine, where we need performance with our native. On the server side, historically, we've always been a Python shop. And in the last 2 years, we are moving more and more towards Go, and I'll touch a little bit about it later on. Our media servers are written in C++, and we have bits and bytes of Erlang for our XMPP servers. And the database, again, historically, we were very much MySQL, RDS at Amazon. And more we're moving stuff out of RDS into Couchbase. We have a few clusters, each one serves a different type of service. We're multi-cloud, our main application at Amazon, analytic pipeline and monitoring Google, and our media server on software and DigitalOcean. I think about 6 or 7 or 8 data centers all across the world. We would like to bring the media as close to the user as we can. We can't do it in CDN because this is live talk, so we need to put the servers closest to the user as we can. Deployment is done via Ansible, and for monitoring we use our own sensor cluster and some new relics, and VictorOps, which is basically something like PagerDuty if you're familiar with it, for incident management and staging. And yes, we use Docker, even in production. Not everything is Dockerized yet, but more and more stuff is getting into that. So we are a consumer company. We have a consumer application. And we needed to know what our users are doing, how they're using the system, what feature works, what feature are not working. And one of the company assets is the data. Google is living on data, Facebook is living on data, and we also understood that we need the data. And we tried for quite a few years to make it work. We failed over and over again from numerous reasons. From technical reasons, we didn't have the right technology, the application wasn't written correctly, we chose the wrong tools, and also from personal reasons, we didn't have the right people to do the job. And we always said that we need analytics, but we didn't put enough attention on it, especially not management attention. So everyone said that we wanted analytics, but we didn't really do it very well. But we kept on trying, and finally I think now we got it right this time. So when we started with one monolithic application, Python application written with Django, I don't know why, we're an API server, no web front end, but it was written in Django. Very slow, everything was served from a single application. When a user was interacting with the mobile application, and events were sent to the servers, the user clicked on that button, the user started the call, ended the call, etc. Also events from the server, meaning User joined the conference, user left the conference, and everything was sent to our main application, the Python application, and event by event, and then for each event, a single insert into an RDS. At the end of the day, everything was loaded into Vertica. And it worked. We were a small company, not a lot of users. We had problems with data. A lot of junk in the data, sometimes the ETL failed, etc. And we had a daily email. And then came July last year. This is where we started, July. This is the graph taken from the Google Play Store. This is only for Android. We have a similar graph for iOS. When we started July, we had about 2,000 new users each day. At peak, we had 80 times that much per day. And those users accumulated. Of course, not every new user become a registered user, and not every registered user become an active user in the system, but we scaled pretty fast. And this former CEO Hoffman used to say, success can kill us. And it almost did. Basically, data collection killed our backend services. Remember, in the previous slide, we used to have one monolithic application, so the users' needs and the analytics needs served from the same place. So a lot of events into the system, a lot of database writes, and the users were unserved. A lot of timeout, a lot of failure, and we had more and more data. The ETL process was written poorly, and it failed over and over again. And it was an ETL process, so hopefully, if everything worked right, correctly, at the end of the day, we started the process, and then maybe tomorrow at 8 or 9 a.m., we had some data. So we didn't have any real-time viewing to events. We didn't know what actually happening in the system. We made a cold decision, cut down all the analytics. Basically, we put an Nginx in front of our server and said, if you go to the analytic endpoint, just return to the user, and we drop everything. So in the times that we grow, we were hyper-growth, we were flying blind. We didn't know what exactly happening in the system in terms of the users. Which feature worked, which feature didn't, where are the user coming from, what they are doing, nothing. So, we started our way out of this mess. First, we took all the analytics outside of the application. The client started to report to a different microservice. We wrote it in Go. It was our first Go project, almost the first Go project. It scales, meaning it handled all the analytics well without disturbing the main application. It was a very naive implementation, but it works. Data was written into Elasticsearch cluster, and then at the end of each day, we had an ETL from Elasticsearch to Vertica. It was good, it worked, but it wasn't good enough. From there, we moved to our core architecture, which is combined of 3 parts. Everything is written in Go, but less naive. We got front ends that receiving the analytics from the users, doing some sanity checks, and then putting the data into a Google PubSub, the service or persistent layer between the front ends and the worker. And then we have workers also written in Go. They are putting data from PubSub and writing that to the data storage. It could be Google BigQuery, it could be Elasticsearch. If we start tomorrow, we decide tomorrow that we're moving to Amazon Redshift, we just need to write a different type of worker and write the data into that.
Why did you decide to use Go?
Can you repeat the question?
Yeah. Okay, why did we decide to use Go? First of all, I'm a geek and I like new technologies, and it seemed like a good opportunity to test it. We needed something that scaled, that was easy to deploy. And I'm coming from a long background of C and C++, and personally for me, it was very logical to try Go. And the curving is, the learning curve was very, very fast. I think in a week or so, people without any knowledge of Go become very productive. Now more and more services, especially as the language mature and the ecosystem mature, are moving towards Go. We're still writing some code in Python, and probably will always be at least 2 languages around, but more and more services, especially the ones that need scale, that need concurrency, Go is the perfect language, at least from my point of view. Okay. The front ends. The client are batching the events, meaning that after each amount of event or X amount of time has elapsed, the client are sending the data to the server. Of course, it's gzipped. the front end is doing some sanity check, validation, versioning, etc. Return to the clients as fast as we can. And we want to close the connection for two reasons. First of all, those are mobile applications, and battery life is very important for us. And one of the big consumer of battery life after the screen, of course, is networking. If we can close the connection fast, there's a chance that we can save some networking on the client side and then save some battery life, and that's good for our user, good for us. And also from scaling from the server point, if there's any need to keep connection open, we close it so we can serve more users at the same time, the same sheets. So 202 accepted to some. The front end are geo-load balance. We think we got them now in 3 or 4 locations in the Google Cloud around the world. And this is one of the advantages that we have, that we are using PubSub and BigQuery. The workers are agnostics to the queue, because the queue is distributed across the Google Cloud, so I don't care where do I put my workers. So we have workers, again, we have front ends close to the users we can. And the analytics are pushed into the PubSub queue for future processing, for mutation. We'll talk about it later on. And basically it's a fan-in model. A lot of writers into single point. So this is those are our workers. They are pulling the events from the PubSub. They mutate and enrich the data, for example, geo IP resolution, etc. And I'll talk about it later when we select a bug that we had that was solved without any client change because of the ability to do mutation. And the workers are inserting the data into various DBs according to the usage. If some DBs we are using for monitoring, some of them for BI, for etc. And each type of worker it sits in a cluster of its own. We have currently we have 2 types of workers, one into BigQuery and one to Elasticsearch. Up until 2 months ago, we used to work with another company, and we also use the same methodology to push our data from the PubSub into the servers. Basically, we put the data into BigQuery, and then we had a process that extract the data that we wanted and put it back into the queue that could send it to this company. So the architecture is working, very scalable, very extendable. And it's a fan-out model, reading from some place and writing if you are place. Okay, streaming into BigQuery. We very fast we understand that putting one row at a time or even batching is not very scalable for us, and we wanted the data to be readily available for querying, especially for monitoring. And we found out that there is a streaming capabilities in BigQuery, but there wasn't any good enough Go library that could do that. So we wrote our own. It's an open source library, the URL is there. Basically it receives the data and then stream the data into BigQuery. Just a continuous stream into BigQuery. It can work in 2 modes, or basically it could work in both of them together. Sync, foreground insert, or async, which is done in the background, and then you receive some more stuff. The data is available almost in a matter of seconds or minutes. From the moment that the client press a button, I can query it after a few minutes, so it depends on client time on when it sends the data. It's very fast. Queries are very, very fast for that. Error handling, it's a bit of a bitch. And from time to time we are getting server error, which I must say we are getting less and less of them over time, but still we're suffering from them. And then we implemented a retry mechanism and a backoff mechanism, and we know how to do that. And library is open source, PR are welcome. Also there is a blog post that we wrote about it. When we released the library, actually the guys at the BigQuery team at Google saw it, wrote it, read about it, also published it in the Reddit, etc. And there's a guy, Felipe, probably some of you are familiar with him, he speaks about it every time he speaks about BigQuery.
Can I ask when you start working with BigQuery?
When, yes.
You start with low jobs, or from the start you use the streaming?
We started with the load, but very quickly we moved to streaming.
Because of
It's easier and we need the data available, ready available, and there isn't any point to store it somewhere and then to load it, to accumulate it. I have the data, why not write it there as soon as I get to the data, the database. There isn't any cost associated with it. Since we have persistent via PubSub, it's fairly safe. I don't care if I fail. Even if one server fails, or two servers fail. The data is there. A little bit about our deployment. The front ends are located around the world. We use the simple load balancing to redirect the client. The workers are in Europe, and the Elasticsearch cluster is in Europe, and there's good reason for that. The only users of our Elasticsearch cluster is rounds. We use it for monitoring, I'll talk a little bit later. And we needed fast access. The access from Israel to Europe is a little bit faster than to the US, then that's why we choose to put the US cluster there. And since the workers are writing into the Elasticsearch cluster and BigQuery is distributed, so it doesn't matter where the workers are, we decided to put the workers near the Elasticsearch cluster. So we minimize our cost, meaning that we don't need to shovel data on our expense bills from US to Europe and vice versa. And we use BigQuery, it's distributed, it doesn't cost us money to put it. So those are the reasons. So now, some technical reasons and some financial reasons. There's a lot of flexibility. Elasticsearch. Anyone that is not familiar with Elasticsearch? Elasticsearch is another Israeli product. And it's a very good one, and it's getting better over the time. We start using Elasticsearch for monitoring and time-based series, I could say. About a year before Elastic called themselves realized that it can be used for that. Every new feature that the developers on the server side and even on the client side is writing, of course there's analytic attached to it. And every new feature received its own dashboard that we can monitor in real time what's happening, if the feature is working, not working, any problems, etc. So this is the first usage rate. Another usage is debugging. Developer writes a new UI or new functionality. Of course, part of the definition of the product is what analytic is related to that. And then instead of going to BigQuery and querying SQL, you can very easy, just a few clicks of the UI, figure out if the events are sent correctly or not. So that's another usage. The last one is monitoring. We use a lot of sensor custom checks to do a lot of, for example, well, video check. One of the main KPIs, how many concurrent video calls we have right now. So we are checking every minute, so every 5 minutes, depends how many concurrent calls we have right now, and compare it to the median of the same day last week, was the same hour, and yesterday, and create alerts. And we have got a lot of checks doing something like that. The data is kept for between 30 to 90 days. I spoke 20 or what?
No, you have.
So speaking too fast. Slow down. So we're keeping the data for 30 to 90 days. We don't need it forever. We just need it enough to have timeline that is valuable for calculation. And we use Kibana for ad hoc reporting. If you're not familiar with Kibana, it's a dashboarding and UI tool on top of Elasticsearch. Very powerful, very easy. You can create all kinds of dashboard. This is just a sample of one of the registration dashboards. BigQuery.
One question
yeah.
regarding the monitoring that we used, took advantage of the Elasticsearch to use the monitoring. Why specifically Elasticsearch is better for monitoring than other databases or?
Like what?
Can you repeat the question again?
Once.
I
figure it out.
And,
The question was why we choose Elasticsearch for monitoring over other databases. So there's TSDB, I think, which when we started was not mature enough. and the visualization and the interface for Elasticsearch are very good. And we also use it for Logstash, for logging, so we've got everything for monitoring in one place. The interface is very easy to use. You've got curl, basically you've got REST API. So it's very easy to use and from visualization point of view and also from API point of view. And it's a great product, it's very scaled, very extendable. So, okay, so BigQuery. If we're storing the data in Elasticsearch from 30 to 90 days, BigQuery store it until the end of time, hopefully. You can access it with some sort of SQL dialect. If you're familiar with SQL, you can do the transition into Google BigQuery thing in no time. It is very, very fast. You don't need a DBA. Our VP of data used to work for Fiverr, and he had about 3 people that were managing his Hadoop cluster. And he came to Ram and said, "You don't have anyone that managed your data?" He said, "No, we don't need it. So you can focus only on querying the data and analyzing it." This is a big advantage, especially for small startups. You don't want to invest in something that is not your core product. And we use Sisense, another Israeli company, for reports. We started using them about 2 months ago. Before that, we had another product that we weren't happy with it. So we moved to Sisense. And they have new beta for BigQuery. It works very well. I hope I'm not insulting anyone that I'm calling them Kibana for BigQuery, but Kibana was first at round, so I'm using the same name. Of course, not everything was perfect. We now have to decide whether or not we want to enforce on the client these event schemes, whether we can let them report whatever they want or make them life a little bit harder and make the server life a little bit easier. Clients make mistakes, and it happens. If it's on Android, it's easy. You just release a new version, but if it's iOS, it's a little bit tricky. You have to wait about 2 weeks. Lately, it's become a little bit faster, but still. So, about a month ago, we released a new product, basically just testing the water for some new concept. After a month, we got about 500,000 users without any publications. Just a nice application. It's called Booyah. It's a video chat for WhatsApp. No registration is needed. Just install it, send a link via WhatsApp, and we've got the video chat. It's very easy. Basically, we use it to test some assumptions, some new UI, some new invite feature, etc. And in one of the first iOS version, we were sending the data, and apparently when the locale is Arabic, the numbers are Arabic. You know that the numbers that we are using today are Arabic origin, the number were in Arabics, and the dates also were in Arabic. And BigQuery didn't handle it because it's based. Elasticsearch handled it very well. So we did 2 things. First of all, the workers did a mutation whenever they encounter Arabic digits. We just replace them with regular digits, and all the data that we missed because of BigQuery rejected, we just took it from Elasticsearch, mutated, and then took it from Elasticsearch, put it into the queue, and then the mutation process worked on it and inserted it into BigQuery. So we were able to fix client bugs in less than probably half a day, including testing, and not waiting for 2 weeks. We are looking at some sort of event definition language. We are not sure that we want to go there. And we wrote a library for reporting from the server side. All the reports are not only coming from the clients, but also from the server. There are a lot of server events that are reported, especially the ones that regarding the call flow. That's it. Any more questions? Okay, I've got 3 shirts for 3 easy questions, not related to rounds.
I have a question related to rounds. Why to use also Google and also Amazon?
Okay, historically we were on Amazon, and we still tied into our deals. when we started to use BigQuery, it made a lot of sense to put all the analytics pipeline there. Because we had BigQuery, we get PubSub, and then we put the workers there, so they'll be close to the PubSub and to BigQuery. And the next stage was moving the Elasticsearch cluster from DigitalOcean to BigQuery. That's the reason.
Okay, thank you.
Yeah.
Did you have any problems with Elasticsearch losing data?
Losing not, but yeah, did we had any problem with Elasticsearch losing data? But we had our share of problems along, especially when we started with Elasticsearch, until we figure out the correct configuration for us. Currently we have a cluster with basically, it's running inside Docker, and we have 3 types of machine. We've got front ends, we've got data nodes, and we've got backends. So we can, if we have more pressure on one side, just increase the data. If we need more storage, if there's a lot of requests, we can add more front ends, etc. But it took us time. We had a lot of yellow and red cluster during the way. But we haven't upgraded to Elasticsearch 2 because they don't have a clear migration path, so we need to wait until all the 30 days or the 90 days of the old data will vanish and we can move to them. Yeah.
Can you describe what issues or the difficulties you had with the BigQuery regarding cost, table partitioning?
Okay, table partitioning. We had a lot of fear from the cost of BigQuery. We're surprised. When we started, Vadim gave us a quote, I think a few $100,000, and I think we finished it up in 2 days. We didn't understand exactly how it's working, what's the pricing model, and now we are paying less for that for a month. So you need to do partition. You need to partition the data smartly, and you need to be aware when you're querying the data. Basically, we are paying now less for querying, and you don't pay for storage, or you pay basically almost nothing for storage. You pay per query, so partition your data wisely, write your queries wisely, don't run until the end of time if you don't need it. And we're paying now for BigQuery less than we used to pay only for the hardware at Amazon for Vertica. Yeah.
You said that you're using Vertica and you change it with the BigQuery.
Yeah.
We are part of a project that uses Vertica.
It's not it wasn't Vertica fault. It was our fault. We didn't know how to work with Vertica. And I'm not saying anything bad about Vertica.
No, maybe that was the question.
It was pricing issues.
No.
And we didn't have the skill set. We didn't have the right personnel. We spent a lot of money from external consulting, etc., trying to work with Vertica and micro strategy. We failed. So we had to throw everything away and start from scratch. I'm not saying anything bad about Vertica, but my experience was not good. Yeah.
You're not related to any particular technology that you're using, but from your experience, you said that you felt you improved things, you got them better. From your experience, what do you think to when you're starting off with a development team to do it right from the get-go?
From the start?
Yeah, from the start.
Regarding analytics or in general?
Analytics and even general.
In general, just get the right people. I think this is 70% of the magic is getting the right people. Don't compromise with people. It's very hard. It's getting the right people. Don't try to build the perfect product from scratch. You don't know what the product will be. So don't over-engineer everything. Don't try to optimize everything from scratch. Do some of optimization, do some of engineering, but don't overdo it first. But getting the right people, I think it's the most important part. Not engineering, not technology, getting the right people. They will do the work. Any more questions? So, question number 1. What is the query engine behind the BigQuery?
I think he will get all of the shorts.
Sorry?
I think he will get all of the shorts.
Okay. Yeah. Okay. there's a nice functionality in BigQuery that enable you to get data, to query data that is not in BigQuery, meaning reading it from file without loading it to the database. Anyone has any ideas for such a use case? Any use case?
Can you repeat the question?
There's ability in BigQuery to query data which is located not inside the database but on a file system, for example. So one particular use case come to mind,
Dimension whitening,
for example.
migration.
Sorry?
Loaded data?
Loaded data and mutation is the same operation, yes. And another one is if you had small amount of data that are changing rapidly, that makes sense instead of putting it into the database, just querying it all the time. Not sure.
Another one,
Sorry.
bingo.
And the last one, the Israeli angle, there's a tool for visualization and querying database. Israeli-oriented, open source. It's also support BigQuery, very nice. What? Redash. Who said Redash? Yeah. If you don't know, Arik used to work for Everything Me, and now he's starting his own company, and I'm using it just to play golf. When I need to do a quick visualization and dashboarding just for me. I've got an instance up and running, and it's working, so if you need something to play around with BigQuery or any other database, you need some kind of visualization, go try it. They got images ready to install on Google and Amazon, just deploy them in, and that's it. So, anything else? Okay, thank you.